In this particular video, we're going to be going over discovering the Pythagorean theorem. So I'm going to be going over the video or the activity with you through the video. So I have everything that we need here, and I'm going to start with reading the directions from the table. On Discover the Pythagorean Theorem worksheet, find the following: the height of triangle A, the base of triangle A, and the hypotenuse. So here is the sheet that we need. Discovering the Pythagorean theorem, and I went ahead, upside down. I went ahead and went on to the next step where you were supposed to color each box. So we need to figure out the height of triangle A. So to figure out the height, you are going to count the squares. So the height of triangle A is 1, 2, 3. Okay, the height, or also the base of triangle B is 1, 2, 3, 4. So that's going to go in my table. And then the hypotenuse, 1, 2, 3, 4, 5. Okay, and then it's asking us the number of unit squares in each box. You're going to count the number of units in each box. So A is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, B, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then box C, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24, 25. 25. And you can also do like 3 times 3 and got 9, 4 times 4 and got 16. 5 times 5 and got 25. And if you have been noticing, or take a notice real quick, that these are perfect squares. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. So now that we have counted the amount of squares in each box, the next one is color, which I've already done for you. And then 3 is cut out the A box and the B box only. So I'm going to pause the video and do that real quick. Okay, so I went ahead and cut out our squares of our triangle. As you can notice, I didn't cut them out in individual squares because I realized I didn't have to, but that is something that you could do. So I could have actually counted or split up the individual units. I just wanted to save some time and didn't want to lose any of them on the ground. So the next part of the instruction was, after we cut them out, to put both the A box and the B box to fit inside the C. The C box, which is this one. So again, I'm going to see if I can get these squares to fit inside of block C. And as you notice, I had to cut them up because they would not fit in as they were. Okay, so there is all of block B. Now block A needed to be split up into smaller sections. Okay, and as you can see, the area, or all of block B and all of block A fit into block C. So yes, they do fit. Again, it was block A plus block B equals or fits into block C. So then as we go into figuring out the rest of our activity, so we cut them out. Do both the A box and the B box fit inside the C box? That is a true statement. Okay, there's my boxes now. They're all in box C, so that is a yes. Okay, and what do you think the Pythagorean theorem is? So it was the area of A, okay, or box A. And when I added the area of B, which was box B, they equaled the area of C, which was box C. So that's one way you can write it. Okay, and the way that we're getting to is we're realizing that the area inside the box is length times width, and then of a square, of a perfect square, that is really 3 times 3, or 3 squared, 4 times 4, which is 4 squared, 5 times 5, which is 5 squared. So we have box A was 3 squared. So if I take the same concept and do 3 squared plus box B was 4 squared equals 5 squared. So that would be 9 plus 16 does equal 25. Okay, and that is all how the Pythagorean theorem works as another example. And so our actual formula for the Pythagorean theorem, so instead of saying area of A, area of B equals area of C, the actual theorem is that A squared plus B squared equals C squared. Because as you can see, these are actually my area formulas. A times A is A squared, B times B, length times width type of thing, is B squared, and C times C is C squared. So again, when I took the squares, each one, if I took 3 squared, which was the area of A, and I added B squared, which was the area of B, I can put them inside the area of C and they fit perfectly. So my Pythagorean theorem is A squared plus B squared equals C squared, and this happens for every right triangle. Okay, the next part of this video, we're going to review parts of our right triangle. So particular parts of our right triangle that we are going to review are going to be the sides of my triangle. So the first one that I want to highlight is the hypotenuse. It is pronounced the hypotenuse, and it is the longest side of the triangle. It's always the longest. And then you can always spot the hypotenuse no matter what way the triangle is facing, because it is opposite of the right angle. So here's the right angle, and I always draw an arrow to the side opposite, and that is where your hypotenuse is going to be. Okay, the sides are called the legs of the triangle. Okay, and the angle is 90 degrees, is also called the right angle. Okay, and I'm also going to go ahead and label the sides of the right triangle for you. So the legs can be A or B, they can flip-flop, but the hypotenuse is the longest side that is very unique. It is always across from the right angle, and this side is always C. C does not change. C has to be your hypotenuse, has to be the longest side, has to be the side that it's across from the 90-degree angle. But this is side A and side B. And again, you can flip-flop A and B, but you cannot change side C. So A and B are the legs of the triangle because they're both identified as the legs. You can flip-flop that variable. C is the hypotenuse, which is always the longest side, always opposite of the right angle. So we're going to practice labeling our triangles, but the one that we have to be able to identify is our hypotenuse. So it gets a little tricky when they are not all facing the way that a right triangle, like we're used to seeing it. So first I want to go in here and place our right angles first. That could be a hint that helps us. So let's say place the right angle in number 1. Remembering that my hypotenuse is the longest side, always opposite of that right angle. So if I draw an arrow for the opposite side, this side is C, which is our hypotenuse, and those two could be A or B. And number 2, my right angle would be here. Hypotenuse is the opposite or the longest side, so C would be over there. Okay, in this particular diagram, here is my right angle. I draw an arrow, so opposite of that, this would be side C. And number 4, my right angle is down here at the bottom. Drawing an arrow opposite of that, this would be side C. Right angle in number 5. Drawing an arrow opposite of that, this would be side C. Drawing my right angle in 6. Opposite of that, this would be side C. So a follow-up question in the exercise above, how did you know the side of the triangle the hypotenuse was? So I looked for the right angle. Okay, and then I also drew an arrow to the opposite side. Okay, so those are some helpful tips in locating where your right angle is. And then also you're using the right angle to find the hypotenuse, which is your longest side, always opposite of the right angle. So these are some key points to know when dealing with the Pythagorean theorem. Continuing with our review of Pythagorean theorem, we are looking at our introduction to Pythagorean theorem. We're going to also review area like we did in the first part of this video. So the directions are to count each unit to find the area of the whole square. So as we look at number 1, I can count up my individual squares on the inside. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Or you can also, to find the area, is count your outside. So 4 by 4. And then we knew from our perfect squares that 4 times 4 is 16. This one is 1, 2, 3, 4, 5, 6. It's a square, so all sides are 6. 6 times 6 is 36. And this one is 1, 2, 3. It's a square, so we know that all sides are 3. 3 times 3 is 9. And again, I did 3 times 3. I did 6 times 6. And I did 4 times 4. So directions. Find the area of each square by counting the units of the length and multiplying by the number of units by the width, which is what I just did with the ones that are up here, and they kind of highlighted it out down here as well. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We know that 9 times 9 is 81. 3, 4, 5, 6, 7. We know that 7 times 7 is 49. 4, 5, 6, 7, 8, 9, 10, 11, 12. And we know that 12 times 12 is 144. So this is a brief review of our perfect squares. So why do you think that squaring a number x squared is called squaring? Anytime that I do like x times x, that's what x squared really is. They call it squaring, and we kind of did this already with our perfect squares. Is it because it creates a perfect square? So anytime I did 9 times 9, whenever I multiply those with an example, a visual, it created a square. So they're called squaring when you find the area, because you are finding the area, and it makes a square shape. So it is called squaring. So in this video, as a recap, we have introduced and reviewed the right triangle. We know that the hypotenuse is the longest side of my triangle. The longest side, it is always opposite of the right angle. So the key to find the hypotenuse, no matter what direction your triangle is facing, is you have to locate your right angle first. Okay, and then I always like to draw an arrow to the opposite side of the right angle, and that is where C is always going to be. The legs of the triangle are your other two sides, and you can flip-flop the variables A and B, but C is always going to be that longest side, which is your hypotenuse. Okay, then we did a brief introduction on how, and the discovery of Pythagorean theorem is a squared plus b squared equals c squared by cutting apart the areas of my squares and then realizing that it fits into the area of the longest side, which was C. And then we came to the conclusion that my equation, or my formula, because this was long to write out the area of A plus the area of B was the area of C. That's a lot. And so the shortcut of that would be A squared plus B squared equals C squared. So this was an introduction video to the Pythagorean theorem, and in the next couple of days we're going to be using this theorem or this formula to really dive into equations. So this is the formula you are going to need to know for like the next couple of weeks. A squared plus B squared equals C squared, and that is your Pythagorean theorem.